In this demo we show the properties of a simple landscape lens that was developed in the early 19th century. It consists of a meniscus lens and a stop placed in front of the lens. The aperture itself is quite small, and if we look at the spot diagram, we see that spot sizes are reasonable and we have some lateral color. There's also some axial color, which is shown here, not very much, and the tangential focal surface is flat and the sagittal focal surface is curved inward. The distortion is quite large, it's about 5%. And this is a typical image of an object placed at infinity. If you look at the sidal aberrations, we see that spherical, coma and astigmatism are in the order of a wavelength. Field curvature is larger and distortion is quite large. Axial color is in order of a wavelength and the lateral color is much larger. This is the full field and we clearly can see the distortion. This is the MTF, and we can see that this lens can be used up to about 4 or 5 cycles per millimeter. It's really not very much. These lenses are used also today in the modern throwaway cameras, because the small aperture is not a problem. If one uses a very high-speed film, the exposure times are still reasonable. And also today it is possible to add some aspheric terms to those surfaces to compensate other aberrations. And those lenses are normally injection molded. For instance, if we want to reduce distortion, we can add some aspheric terms to the surfaces and re-optimize the lens. And then we end up with a lens which is more or less similar, but with the stop moved further away from the lens. If we now look at this graph, we clearly can see that the distortion is about 1%. As can be seen here, the distortion is much less. At the same time, we see a small blur which starts appearing at the edges. So the performance is not quite as good for the other aberrations. For instance, we can see that the lateral color has increased quite a lot. If you look at the sidal aberrations, you can see that spherical aberration has increased slightly, coma has increased quite a lot, astigmatism and field curvature are lower, distortion is much lower, axial color is about the same, and the lateral color has increased. If you look at the MTF, we see clearly a drop in performance. So on the one hand the distortion is better, on the other hand the performance is overall lower. Also today it is possible to add a diffractive surface, or to add a diffractive function to one of the surfaces to compensate the color aberrations. this can be shown as follows. We put a binary surface here, and we re-optimize, and we see some improvement. The lens now shows like this, and we can see that we have to increase the dimension, the diameter of the lens, in order to get all those field rays through, because the stop has been moved even further away. But now if you look at the spot size, we see that the lateral color indeed has improved. The distortion is comparable, and if we look at the overall performance, the MTF, we see that overall it has improved quite substantially now. So this is an example of a very old camera lens, but by using modern technologies like aspherics and diffractive surfaces, one can use this lens even today